guys, first of all, I'm so sorry for uploading this late, but I just got free time right now. I really hope the video helps you on your packet that you have for homework, and I also hope that you enjoyed this intro of the calculus channel.
Alright guys, I'm back. Let's go ahead and practice with number 1. And I say practice because number 1 will help you for number 20. But anyway, it says use the limit definition of a derivative to calculate this derivative. So you guys already know that the answer here, f prime of x, is equal to 3x squared minus 3. Okay, so we just have to use this limit definition to get my answer. And I already wrote this down here. Recall the definition of the derivative is this limit right here. So let's start. So we have the limit as h approaches 0. All right, so everywhere we see an x here, we're gonna plug in x plus h. So I have x right away, so let's plug in x plus h cubed minus 3 and x, so x plus h. So right there, I just plugged in x plus h everywhere I saw an x here in my original. So that right there is only this part that I'm circling right now, okay? Minus, well, you always subtract the original, and my original is x cubed minus 3x. And please put it in parentheses because that minus sign will be distributed all over h. And now we just have to simplify and things will cancel, and whatever you have left, it should be identical to this, 3x squared minus 3. So I'm gonna go on a little detour like I do in class. And x plus h cubed will be equal to, and I already did it on this side, I'm just gonna go ahead and copy it down, x cubed plus 3x squared h plus 3xh squared plus h cubed. So all that mess right there is just this first part, okay? So I'm just gonna go ahead and distribute this negative 3 here in the minus sign here. So then I would be minus 3x minus 3h minus x cubed plus 3x. And I'm going to go ahead and do all of that over h. Ooh. Okay. Things should cancel here. I have my positive x cubed cancels with negative x cubed over here, negative 3x with positive 3x here, and that looks like that's it. Okay, so then I'm going to continue over here because I'm out of space. So then I would have the limit, and here, let's cross that out already, the limit as h approaches 0 of whatever we have left. So 3x squared h plus 3xh squared plus h cubed minus 3h all over h. Now I have every single term has an h in it, so we can cancel one h out. So those h's cancel. And now what we have left here will be 3x squared plus 3xh plus h squared minus 3. And now we take the limit, we do direct substitution here, plug in, oh my gosh, I didn't write the h there. Plug in h equals to 0 everywhere we see an h. Well, we see that this term will leave, this term will leave, and all we have left now is 3x squared minus 3, which is what we wanted. That was our derivative up there. Okay, so this is gonna help you with number 20. Here, let's look at number 20. That should be the last page. Okay. All right. That's the definition of the derivative there. If you guys remember, it was this part that you're taking the derivative of, correct? The g, it doesn't matter what variable we're using, f, g, whatever. This part is your x plus h part, and you always subtract whatever you're taking the derivative of, okay? So in reality, this right here is asking for g prime of 3, and guess what? That answer is up here. It will be 5. You literally don't need to do any math. You just have to recognize that this is the definition of the derivative, so you're just taking the derivative of this very last part, the part that you're subtracting of, and that's it. Okay, so that was that. Now let's help you a little bit with number 3. All right, find an equation of the tangent line to this graph at this point. Okay, remember, to write a tangent line or normal line, you need 2 things. That is a point and a slope. Okay, well, the point here, my x is pi over 2. My y, well, to get a point, you always plug into the original. So my original here is this guy. So y of pi over 2, you're just going to plug in pi over 2 here to the original. So I have cosecant of pi over 2. Well, cosecant is related to sine because that is its reciprocal. So what I always like to do is I like to go ahead and figure out what sine of pi over 2 is, and then just flip the numerator and denominator, because that'll be my answer. And sine of pi over 2 will be 1. And if we flip 1 over 1, well, we can make it a fraction, and if we flip it either way, we're gonna get 1. So my y value here is 1. And my slope, well, I need to go ahead and take the derivative of my function. So I would have y prime is equal to, well, remember I said that all the derivatives that start with the letter c here of my trig functions will always be negative, and the derivative of cosecant is cosecant cotangent. So cosecant x, cotangent x. And now we just have to plug in my pi over 2 everywhere I see an x. So negative cosecant of pi over 2 and cotangent of pi over 2. And use your hand trick or use the unit circle. We already figured out cosecant of pi over 2 earlier, but now it has a negative sign in front, so negative 1. And cotangent of pi over 2, well, think about it, and let's do it here. Let's do a little detour. Cotangent is the reciprocal of tangent. Both of them have a t in it. That's how I would remember it when I was in high school. So what I'm going to do is I'm going to go ahead and figure out tangent of pi over 2. Well, tangent is sine over cosine. Okay, so do sine of pi over 2 over cosine of pi over 2. Sine of pi over 2 is 1. Cosine of pi over 2 is 0. But if we flip it, because we're trying to do cotangent, we would get 0 over 1. And 0 divided by 1 is 0. Okay? Because what it is right now, 1 over 0, that's undefined. Okay? And 0 times negative 1 is just 0. So my slope here is 0. So if I plug into my point slope form, which is this guy right here, we get y minus y1 is 1 equals to m, well, m is 0, x is pi over 2, or sorry, not that x, sorry guys, x minus pi over 2, there you go. Okay, well, on the test it's never going to be written that way because of that 0 there. So you guys see how if I distribute my 0 here, it's all going to come down to 0. So this will be my final answer, y equals to positive 1. Because all of this side will be equal to 0, and if I move over the 1, it'll become positive. So that's my answer. And for number 4, I'm only going to give you a hint. It says find the velocity of the object. Well, we haven't really talked about this in class, but we definitely will very, very soon. Use the acronym PVA. This stands for position, velocity, and acceleration. So just like this if we go this way, you are taking the derivative. So the derivative of the position function is velocity, and the derivative of velocity is your acceleration. Okay, that should help you there. And that'll be it for all of this. You guys should be able to be be able to do the rest of it relatively easy. If you have questions, ask me down in the comments. Bye.